Okay, John Ferrera, okay.
Gotta do it for free.
John, the vibration from the
They
volume.
call that
Actually, no.
All right.
After 2 years, I got paid $450 because I got paid because it's under 500 now. You don't get taxed.
All right. So,
Wait, really?
so sampling. We've done samples before. We've taken samples before. Okay. Distributions. We've looked at distributions before. Distributions are things like graphs, looking at a set of data. We've done those. We have never done them together. That's what chapter 7 is. Distributions of samples. Okay. So sampling distribution is a collection of a large number of sample statistics. Means or proportions. Means are averages, right? A bunch of averages, or proportions, right? Fractions, decimals, percents of a given sample size. Okay, so from now on, we're going to look at things based off samples, sample sizes. Okay. It's not sample distribution, it's sampling distribution. Okay. Okay, so there's two things. One is a parameter, one is a statistic. One of them we've been looking at, one of them we haven't. Parameter, what is a parameter? Okay, so a parameter is a number that describes some characteristic of the population. Okay, so if we're talking about the population, that's a parameter. Okay, in statistical practice, the value of a parameter is usually not known because we cannot examine the entire population. If I wanted to know, the average, the average height of all males in the United States, I don't think I could get that because there are so many. There are so many, right? And it's not known. That number is not known. Okay. But what I could do is I could take a sample of men in the United States and find their average height. That would be called a statistic. Okay. This class is called AP Statistics because that's what it's based off of. It's based off taking samples. So a statistic is a number that describes some characteristic based off a sample, not the population. It's based off a sample. Okay, that's the difference between the two. Seems pretty simple, but this is one of the biggest things that students struggle with. Okay, and we'll do some practice here in a second. But the value of a statistics can be computed directly from the sample data. We often use a statistic to estimate an unknown parameter. Okay, parameters are based off the population. Statistics are based off of samples. Okay, that's how you can tell one from the other. All right, we're going to look at some in a second here. So parameters are based off population. Statistics are based off of samples. Okay. Okay, so if you look up here real quick, the population is the big part. Sample is a subset of that. Okay? So just because population, when you see the word population, you think big. It could be big. Population could be all males in the United States, all females in the United States, all residents of Fresno County, all students at Central High School. That's a big number. All of those are big numbers. Or population could be the students in room 87 during period 7. That's you guys, right? That's only you guys. You guys aren't a big number, right? So be careful with population. People think population's big. It can be big and it can be small. Okay? A sample is always going to be a subset. It's always going to be smaller than the population. Okay? So if my population is students in room 87 during period 7, My sample, I could randomly take a sample of 3 or 4, right? If my population is all students at Central High School, now you're talking close to 1,000 students. So my sample could be like 100 or 200 or 50 or 20, okay? So it just depends, right? But the sample will always be smaller than the population, okay? We collect data from the sample to make inferences. What does inference mean? Where have you heard that word before? Inference. There you go. It's an educated guess about what's going on with the population. Okay. All right. Okay, so let's go back here. Parameters versus statistics. Parameters deal with the population. Statistics deal with the samples. So we have 2 types: means, averages, proportions, percents, right? So we're going to use some symbols here. We've been using symbols quite a bit already, but we're going to use some symbols that look familiar. Okay, so if I'm talking about a population, and I'm talking about the mean of a population, I'm going to use this symbol here. It's the Greek letter mu. It's like a U with a little tail on it. We've seen that before, right? But anytime I use that from now on, it means population. It doesn't talk about the sample. What if I wanted the mean of a sample? That's the one you see on your calculator. The one you see on your calculator is X bar, right? So if I see X bar, that means it comes from a sample. If I say mu, it comes from a population. Okay. So if you look at your paper or you look at a question from now on, and I said mu equals 123, that's everybody in the population average. If I say X bar equals 123, whatever 123 is, that means only people from the sample I averaged, not everyone in the population. Okay, so that's the difference. Same thing with proportions. Proportions. If I take the proportion of everyone at Central High School who has blonde hair, that would go up here, right? If I take a sample and ask the same question, that's not P, it's called P. It's got a little hat. It's called P hat. That one's a new one. So how we say it is P hat. It's got a little like triangle caret thing above it. This is X bar and P hat. Okay. So be careful when you're using symbols. One is for population, one is for proportion. Or one is for population, one is for statistic. Okay. All right. So now let's look at an example here. Number 1. So for each, identify whether the numbers underlined, and there are no numbers underlined. Let me fix that. The numbers underlined represent statistics or parameters. Let me see, which numbers should have been underlined? Oops, wait, where is it? Here we go. Okay, the part that should have been underlined is here. So underline it on yours. That should have been underlined, and that should have been underlined right there. So match mine to yours. So letter A, of all US kindergarten teachers, 32% say that knowing the alphabet is an essential skill. 32%, does that represent a parameter or a statistic? It does represent a parameter. Why a parameter and not a statistic?
It says of all U.S. kindergarten teachers.
Exactly. Nowhere in there does it say anything about a sample of U.S. kindergarten teachers. It says all. That's the population. So if it's the population, it's going to be a parameter. And 32% is a proportion, right? So are we going to use P or P hat for this guy? There you go. So we would say P equals 0.32. 0.32. Because P is always a decimal, not a percent. Okay, that's how we would write it. Okay, letter B. Of the 800 U.S. kindergarten teachers polled, 34% say that knowing the alphabet is an essential skill. 34%. Is that a parameter or is that a statistic? That's a statistic. So how do I represent 0.34? Which of those symbols, of those four symbols from the last slide? P hat. Good. There we go. Okay. I have a question. They asked the same teachers, right? So why is one 32% and one 34%? Isn't it the same question? Why are the percents different? So 800 is the sample, right? So maybe those 800 were the same teachers up here, right? Because this is the subset, right? This is all the teachers. This was the sample, right? So maybe these teachers they got here had a higher percentage opinion than the rest, right? So what would we expect about the rest? Would it be higher than 34 or lower than 34? Lower, because overall it's 32, right? So they would need to balance each other out. Okay. All right. Let's look at the next slide. There's some more questions on there too. So I want you to do number 2. I'll give you 3, 4, 5 minutes. A, B, C, D for number 2. Nothing's supposed to be underlined. Okay. Of the US adult population, 36% has some sort of allergy, has an allergy. A sample of 1,200 randomly selected adults resulted in 33.2% reporting some sort of allergy. Okay. Who is the population? There you go. All US adults. All US adults. Oops. Okay. Sometimes I'll have students put adults. Yeah, but we want to be as specific as possible. It's all US adults. If I just put all adults, is that world adults? Is that from a country? Where does that, so make sure you're specific as possible. Okay. What is the sample or who are the sample? 1,200, good. There you go. Randomly selected US adults. Just like that, perfect. 1,200 randomly selected US adults. So the number, so for samples, so when you're doing a sample, the number is important and the description. For population, you don't need a number. It's everybody. Okay. So identify the statistic. So which one is the statistic? 36% or 33.2%? There you go. 33.2 is the statistic, and that's a proportion, right? So we have two options, P and P hat. That one's going to be p hat because it's a statistic. And then this one right here is just plain old p. Okay. Okay. Do number 3. I'll give you 2 minutes. Do number 3. It's only got 2 questions. There you go. All students enrolled at NCSU. Enrolled. Who is this population? At NCSU. Okay.
Oh, but it's a state university.
All right. Okay. Next thing, sampling variability. Sampling variability. This basic fact is called sampling variability. The value of a statistic varies in repeated random samples. To make sense of random sampling, we ask, what would happen if we took many, many samples? So a perfect sample distribution would be taking an infinite number of samples. If I took an infinite number of samples of a population, that would be perfect sampling distribution. Now I know we can't do that. It's not possible, but that's what our ideal is. So that means as you get closer and closer to an infinite number of samples, you'll get closer and closer to the true answer, the true parameter. Okay. All right, we're gonna do a little experiment here. I'm gonna give you a deck of cards. Okay. Give you a deck of cards. First thing you're gonna do is we're only gonna use the black and red ones. So well, what I mean by that is the non so jokers and all those other things. I think those are still in here. We don't need those. Everything else is okay. So you should have 52. Okay, 52. So take out the jokers, take out the like instruction cards. Take out all of those and then shuffle them up as best you can. If you don't know how to shuffle, just turn them over and shuffle them.
There's 2. There's a colored one and there's a black and white one.
Nope. Just you should have 52 cards. So I had 2 jokers and then tips. Make sure there's no tips card in there. Information card. They might not be in the front or the back. They might be in the middle somewhere. Just make sure. Just shuffle right now. Just shuffle right now.
They're hard to shuffle, man.
Yes.
There's extra cards there, man. That's so late. Oh my god. Whoa. Bro. Bro, they're all basically
So just shuffle real good. Once you shuffle real good, you're ready to go. I don't know how well these cards have been shuffled before. So just make sure they're shuffled best you can. Okay. So the instructions are up there. So you're going to shuffle your deck of cards and you're going to pull 10 cards. Okay? You're going to pull 10 cards, turn them over so you can look at them. Okay, so okay, so you're going to look at all your cards. We only care about color. We're not looking at the actual value. We're just looking at color. So the directions say record the number of red cards. So out of those 10, record the number of red cards. So like for example, I got 1, 2, 3, 4 red cards. So it'd be 0.4. Okay, whatever your number is, write it down. Okay, we're going to do it a couple times. Okay, so once you get that number, shuffle again. We're going to pick another 10, but make sure you shuffle. Don't reach back in, just make sure you shuffle before you do it.
For the same 5. Oh, I have rules in here. Uh-oh.
Take those out.
Oopsie.
To be fair, they have more red than black. No, they have more black than red.
Okay, so once you're ready to go, pull 10 again.
Yeah.
So count the reds. 2. I got 5 that time, so I got a 0.5. Okay, you're gonna do it one more time. We're gonna do it one more time. So you should have 3 decimals by the time you're done.
Rematch? Rematch? For all the marbles?
For what?
For all the marbles?
For all the marbles? What marbles?
When we get to what we did on this?
When I had 3 aces and you had a pair of aces and I won because I had 3 aces. Dude, that was crazy. All the aces were on the board. I had a pair of them. And I won.
I do not want to play against you.
Well, we're not playing with money against me.
I'm not doing money against her. No.
Guys.
You're not fun to gamble with.
Why?
Because you just win.
What? I can't control that.
I'm a gambler, but I'm a good gambler.
Anyway, I just threw kind again.
There's no point in gambling if you're just gonna lose.
You got it all because of gambling. Why did you gamble and do it?
Okay, so I need you to have 3 decimals. 3 decimals. You're not going to do anything with them. You're just going to, what's the proportion of reds that you got the first time, the second time, the third time? Okay. Okay, so once you got those three, you're good.
We're supposed to do 5 in total, right?
We'll do 5 in total, but just 3 for right now.
Oh, crap.
So just do your first 3.
Nice. Whoops. You're ahead of the curve. Whoops. I'll delete the last one that I did.
Okay, so on your fingers, tell me. Anybody get 0.1? Anyone get any 0.1s? Anybody get any 0.2s? Anybody get any 0.3s? 0.3s. On your hand, tell me how many 0.3s you got. 1, 2, 3. So we got 1, 3, 5. Okay. So make your graph look like mine. Okay. So we got 5 0.3s. Yeah, we'll do 0.4s right now. So 5 0.3s. All right, 0.4s. Raise your hand if you got 0.4. Show me fingers on how many 0.4s you got. 1, 2, 3, 4, 5, and I got 1, so that's 6. Okay. 0.5s. 0.5s. Put on your fingers how many 0.5s you got. It's 0.5. So 2, 3, 4, 5, 6, 7. You got a 0.4? Okay, so let's do 0.5s again. 0.5s again. I lost count. 0.5 again. Put your fingers up for 0.5. So we got 2, 3, 4, 5, 6, 7, 8, 9. 9 X's. Six, 7, 8, 9. 9 X's, 9.5s. Okay. 0.6s. 0.6s. Put your fingers up for 0.6s. 1, 2, 3, 4, 5, 6, 7. 7. 7 X's. Point sevens. 1. How many? 1, 1, 1, 1, 4. 4.7s. Anybody get 0.8s? 1.8, 1.8. Just 2? That's it? Okay, so 2 of these guys. Anybody get 0.9? No 0.9s? Anybody get 100%? One way or the other? All right. Okay, so let's take a look at this. So everyone's X's should be up there. We should have 36 X's up there. I haven't counted, but that's how many it should be up there. Because each one of us did it 3 times. Okay? So what are you seeing here? What are some things, some overall takeaways that you're seeing right now? The range is from 0.3 to 0.8 for sure. Highest to lowest. What else are we seeing? It's roughly symmetrical. Where's the high point? 0.5. Does that make sense? That 0.5 is the high point? Why would it make sense? Those of you that say yeah, why would it make sense that 0.5 is the high point? Exactly, right? I know the parameter. What is the parameter? All cards in all of our decks, right? That's the population. All of these cards, right? And what do we know about the reds and the blacks in all of our cards? There's 26 of each. There's 0.5. So I know the answer. It's 0.5. Why am I getting other things that are not 0.5 then? Why am I getting, I got 0.4. Some of you guys got 0.3, 0.6, 0.7, 0.8. Why are we getting those if we know the answer? Exactly. This guy right above. Sampling variability. Sampling variability. Each of us took samples, right? We didn't use all 52. We only used 10. Our sample was 10, right? That happens. It's called sampling variability. What's going to happen? Let's say we were to do that 3 more times. It says 5 on there, but we're going to do it 3 more times. What would happen if we did it 3 more times? What's going to happen to the picture, the overall picture here? If I were to do it, everyone was to do it 3 more times. Let's make some predictions. What do you think the picture would look like? Would it still be symmetrical? Would 0.5 still be the highest? Would there be, would the range get wider? What would happen? What do you think? 0.5, 0.6 is going to be the high point. You think it'll get a little wider? Okay. All right, let's see. Do it 3 more times. Shuffle up, and deal. 3 more times. It says 5 on the paper, but we'll do 3 since we have a small group.
Oh man, that's still Mariana look.
Huh?
Alright. There are ways to check if this is fake.
Yeah, I know. I was reading that.
Yeah. The Motor brand poker has a core layer in purple, so you can check the authenticity by tearing the card.
There's the fake one.
What? What does core layer even mean? Like what the
Middle
thing's
layer
made
of
out
the
of?
card. The middle layer of the card. So
So if I like rip it in half, I see purple?
yeah. score down the middle, it would also be crazy.
Wait, did you do it first? I just needed that part.
Who's gonna make fakes of these cards? Are they like antique or something?
0.9 red cards though.
3.
You got 0.9?
I got 0.9 right now. The only one that's not red is an ace.
All right. So once you got your other 3, you can put the cards back in the deck. Put them all back in, even the ones you took out. All right. Okay, so let's do any 0.1s. Anybody 0.1s? So these are your last 3. The last 3 that we just did. Not the first 3. The first 3 are already on here. 0.1s. Any 0.2s? 1.2. So let's add let's add an X to a 0.2. 0.3s. 2, and I got 2, so that's 4. So add 4 more X's to 0.3. 4 more X's to 0.3. All right, let me change the color so that you can see. 0.4s. How many 0.4s? Fingers 0.4s. 0.4s. 2, 3, 4. 4 more to 0.4. 0.5s. 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 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 more X's to 0.5.
Isn't that the same amount that we got earlier?
Might be. 0.6s. 0.6s. We got 1, 2, 3, 5 total. 6 total. 6. 6.6s. 7. 7.6s. Okay. 7.6s. 0.7s. 0.7s. 2, 3, 4. 0.7s. 4. 4 more. Okay. 0.8s. 0.8s. 1, 2. Okay. 2 more 0.8s. 0.9s. We got 1. Okay, we added 1 there.
Well, I mean, the range went up.
The range did go up. Okay, so let's sit back and look at. What are we seeing here? Which one is growing the fastest, taller? Does that make sense? That makes sense because we know P. These are all P hats because it's a sample of 10, right? But we know P. P is 26 out of 52. 26 out of 52 are red. So we know the true answer. We won't always know the true answer, but the reason we're doing this is because is the true answer kind of showing itself? That's a sampling distribution. If you do it enough times, if you take enough samples, the true answer will eventually reveal itself. Okay? So if I were to do this 3 more times, and then 3 more times, and then 3 more times, and then 3 more times, what do you think would happen to the 0.5? It would get the most tall, right? Would the others grow? Yes, but not nearly as fast as the true proportion. And that's what sampling distribution will tell us. It'll always reveal the true answer. The more samples you take, A true sampling distribution would do this an infinite number of times. But I don't want to do that to you guys because then you guys would be here forever. Okay? So we did 6 samples each, and the true answer starts to reveal itself. Okay? We'll pick this up tomorrow. No, there's no assignment, no new assignment. We're just going to pick this up tomorrow. We'll finish. All right? Cards, pass them up. Just make a stack in the front.